What we have here is in red the graph of sine x, and in blue we've got our Taylor approximation. And in this case, we're only going to use the very first term of our Taylor approximation, 0, and then the next term represents our remainder term, where we can change the value of b to get us either closer or farther away from that point. So again, if b is bounded, 0 is kind of the edge of the boundary, and it doesn't give us a very good approximation for the sine of pi over 2, which is equal to 1. But as I move it along that line, I can see that at some point here around point, looks like about 0.87, 0.88, okay, that's going to approximate the y value of sine of pi over 2. And as I keep going closer to the other edge, which is pi over 2, because remember that's the b value is bounded between 0 and pi over 2, we can see that at the edges I have our maximum error for that term, the first term approximation. Again, this is only using the first term. Now, I could also then use the next term, which is going to be the cubic term. And our cubic term, again, is the b value is going to be bounded between 0 and pi over 2. But we can see that the boundaries at 0 and pi over 2, we have our maximum error. But somewhere in between, I can see that I can make that green line match our y equals 1 at pi over 2. In this case, it's somewhere around there. Okay, so we know that b value exists, and we know it exists between 0 and pi over 2. In this case, we can get it pretty close by kind of estimating that. We can get an even better approximation when we go to the next term. And you can see that between 0 and pi over 2, we have very good approximations.